Hey everyone, Trent Pepicelli here from Innovative Marketing Systems. I'm here to talk about the TOSH Micro 90.
Aren't all pad printers the same?
Why, no they're not. Hold on, you want to see some features here? Okay, first off, you may be looking at this and saying, where does the compressed air go? It stays in another part of the shop because it doesn't go on the Micro 90. What we've got is a single power cord that you can, with a transformer, plug into a 110 volt outlet, turn the machine on. Here we are. Now, if you're used to your own pad printers, your older pad printers, what you're looking at is a machine typically that has a lot of knobs and components on the side to do your adjustments. With TOSH, everything that you need is right here at the touch of your fingers. The machine is 100% electric, stepper motor driven, which means you have control over every axis of motion, pad up, pad down, over plate and over part, cliche in and out, and the speeds in all of those different directions. So move the Guardian from the machine so that you can see it in a little more detail. The machine is unique in the market in that it's a single cast component machine. The entire body of the machine is cast in one large section, and then actually when it's pulled out of the mold, the axis panel is sheared off, the inside is machined out, and then all the components are put in. So what you've got is a very compact, very tight machine that's where every component of it is designed for functionality. The casting isn't just a cover, it's actually used to add rigidity to the machine because the machine is extremely rigid in all of its axis of motion. The back end is held with a clamp onto a post. This post can then be, there are different lengths of these posts. There are ones specifically for going onto automated systems. And you have the opportunity to put this machine on its back or flip it over upside down or use it in a normal standard configuration like this. Obviously there's a gross height adjustment here as well. Okay, so we talked about this a little bit at the beginning, but there is no air coming into this equipment. That allows for a substantially more compact design because the motor itself is only about this big. So we don't have a number of need for a large throw for a bunch of cylinders or for horizontal and vertical travel. Everything is belt driven off of the stepper motor drive, and the motion of the machine is very interesting. We'll get to that in a little bit. However, just to finish up the mechanics of the machine, each axis of travel, the horizontal and the vertical stroke, are controlled on linear bearings rather than Thompson shafts or something of that nature. So you get extremely rigid, extremely accurate travel on the plate and on the pad, so your accuracy on each part or each print is under plus or minus 0.05 millimeters. Other machines where you're just cycling them or hoping that things are in the right place, you have an opportunity on a piece of TOSH equipment, because it's electric and motor driven, to do certain things. In hand mode or setup mode, you have an opportunity just to dock to the plate, like that. Or simply cycle the pad. Or stop and look at the plate and wipe the plate off, clean it, see where you are. Or compress over the plate. Now those are all pretty useful, but there's another feature on the machine that's substantially more useful that is exclusive to us on the market. And this is true in all of the TOSH equipment, not just the smallest machine in the range. This goes through our large machines as well. We could put it in what we call stepping mode and walk the plate out. So there are a lot of reasons why that's useful. You may be setting up a fixture and not sure if you're going to have plate interference, or you may want to be able to see it doctoring and see exactly what's going on. You're not sure exactly how your cup is set up. So it gives you an opportunity to do that. The next thing you can do is walk your pad down millimeter by millimeter and adjust it as you need to until you get it into the right position on the plate for yourself. Now, the other choice, of course, is that, or the other option here is, as you move it down, you get it to the correct compression rate, and all you do is hit enter. It's now learned that, as opposed to you adding a few millimeters at a time to get it where it needs to be. And it backs out. And it's in the memory now for going forward. That works both over the plate and over the part. So I can do that, hit enter, and I know I've got a good transfer. Of course, these can then be saved into the program memory, which the machine has 25 slots for memory, which is a useful thing if you have running multiple different jobs. Also good if you're doing medical device or medical stuff because you have everything saved in memory and you can document it that way. So let's just take a look. I've come out of hand mode. I'm just going to put it on single cycle and let it run one cycle. So that's how easy it is to set up the machine and get it to work. Okay, now I'm going to talk a little bit about the speed controls on the machine. Unlike a pneumatic machine where you're simply turning a knob to slow the flow control down on the cylinder and then waiting for your air lines to fill or hoping that something else doesn't turn into the factory and slow your machine down. With this machine, because it's 100% electric, you have an opportunity to simply turn it on, set a speed, and it will maintain that speed because that's obviously the way stepper motors work. In this instance right now, I have it set at the slowest speed the machine will go. It's running, and there's a counter cycle on a cycle counter on the machine that tells you how many cycles an hour it's running. Right now, it's running 440 cycles an hour. Now, I could just turn the machine up, but I have an option when I go to setup mode to change all of the speeds. I can change every axis of motion. I can change. I don't know if you can see that. Mm-hmm. There you go. So right now, what I'm going to do is just I'm going to turn up the doctoring stroke to 3, and I'm going to turn up the inking stroke to 3. And then we'll just put it on single cycle and see how it changes the machine. So you can see clearly we have, again, 2 different speeds there. This motion, I've sped up both forward and backwards, but not increase the pad stroke. Now that may be helpful for you when you're doctoring the plate if you've got a difficult image or something you're trying to do. Now I'll also speed up the pad downstroke. So I'm going to go down to onto object, and I'm going to speed that way up. I'm going to speed it up to 5. See what that does. Still slow there. High speed down onto the part. So what I'm trying to portray here is that we have full control in every axis of motion, which when you're pad printing, because of the nature of what you're trying to do, which is get the solvent to evaporate at a certain speed, this gives you an opportunity to control the process with the machinery rather than simply adding more thinner. The other benefit is, of course, is that you can grab speed out of the process wherever you can. And if you know anything about how we function, we're all about trying to automate the process and improve your cycle times. So I'm just for fun, I'm going to turn it up all the way and let it run, and we'll take a look at what the cycle is. Rather than 430 cycles an hour, let's see how fast it actually goes with a pad in there. So this is a legitimate kind of setup here where we know how far everything is away, we know that we are actually printing, and we'll see how it works. So I'm going to go back to hand mode, take the speeds, and I'm just going to turn them all the way up. All up to 5. Okay, so everything's at full speed. Now I'm going to just put it in continuous so we can get a good count, and we'll just go. Now the machinery is running at just under 1,600 an hour, 1,597 cycles an hour. So you have a full speed adjustment range from 430 parts an hour to 1,600 pieces an hour. So you have a lot of opportunity to adjust your process as it's needed. So now we're going to talk about the timers on the machine. Right now I'm just running without any timers, kind of at full speed. Actually, I do have little timers in, but they're not affecting the cycle time. So I'm going to go to hand mode and show you what these timers are. Timers or print delay or things of that nature are available in the industry in various parts or on machines. Sometimes there's a delay before print or a delay before pickup on certain machines. Because we have a 100% electric machine, you have the opportunity to put delays into every part of the cycle. which can be incredibly helpful when you're doing highly technical or highly difficult applications, or just on a day-to-day basis when you don't want to make ink adjustments, pull your ink out of the machine, and you just want to change things a little bit so that you get a good cycle, you get a good clean print with a good cycle rate. So the timers that are available on the machine are, like I said, in every aspect. You can do a cycle delay, so you can put, if your operator needs a little bit of time to put the part in and out of the machine, you can put that in. Each of these are up to 2.5 seconds on the machine. So before printing, so I'm just going to add one before printing. I'm going to add, let's call it a half a second before printing. Close enough. And I'll put it on single cycle, and you'll see it'll pause before it comes down and prints on the ball. So you see the cycle delay there. Let's do it again. Now it's possible, like I said, to do this in every axis of motion. So I can also do it before pickup. And I'll do these a little bit shorter so we don't spend as much time. So now there's one before pickup. So there's a 1/4 of a second over the plate. There. And then still the other delay is there. Now there's also a onto object, which is onto the part itself, which is incredibly useful, and as far as I am aware, we're the only people in the market that have this. Now a lot of the time, I'm going to increase this delay so it's quite a bit of time on it, so you can see it. I'm going to increase it to half a second. But normally you wouldn't use it this long, but I'll tell you why you would use it. So I'm just going to let it run and talk about it a little bit. You can see, now obviously we've been printing in the same spot, so it's a little bit of a mess, but we're sitting on that part for a half a second. What we found is that even a 1/10 of a second delay, or less than that, when you're having problems with textures or surfaces that don't want to accept the ink, that small pause on the surface of the part allows the air to escape and get you good transfer to bridge any sort of textures. If you're printing conductives or radio opaques or adhesives or anything that's difficult to transfer, this feature on the machine alone is worth the money. Okay, so that was a quick overview of some of the electronic features of the machine. I wanted to just, there are a lot of options within the controls that I haven't had a chance to talk about because we don't have some of the features present. You have an opportunity to put a rotary table on this machine that's totally controllable through the keyboard of the machine. A nice little dial, 490mm dial with 2, 4, 6, 8, or 12 stations, totally programmable through the keyboard of the machine. You have an opportunity to put a linear indexer, a 300mm all-electric linear indexer on there, which is totally programmable through the keyboard of the machine. There are videos that we have available that you can see of these things running. But there are a lot of details in here that are not useful to show you if I can't show them working together. In any case, we can talk to you about them if you'd like to. One other thing I just wanted to show you, and this is a little, I don't have a part here in front of me, but I'll just we're going to use this Kleenex box as a part. Any machine on the market that you look at doesn't have the type of throat that we have on this machine, and it's a really critical component to the machine itself and useful. I'm going to just pull the fixture off for now because we're not quite set up for it, but I want you to be able to see this. If you had a larger part like this and you wanted to print in the middle of it, let's say it was square, and you came up to the front of a typical pad print machine, there would be the knee of the machine, you end up hitting the part here. With ours, it's wide open underneath the machine. So you have an opportunity to put a much larger part on and print in the middle of it on a smaller machine like this. This gives you an opportunity to do a huge range of activities with the machine that you wouldn't typically be able to do. The other thing to keep in mind is, unlike some machines on the market, we haven't stored our electronics or important components underneath where the ink goes. So when you have a disaster, which you'll have because you're going to pull that ink out one day, you're not going to be paying attention, it's going to fall all over the place. Where's it going to fall? On the floor or onto the tabletop. It's not going to fall into your machine. So you've got a job of wiping things up rather than replacing electronic components in your equipment. That's it. Thanks for listening, and I'm sure I'll see you soon.